Okay, so what is Git, GitHub, and Bitbucket? Git is a protocol for version control. It helps you keep track of changes to code-based projects. And it's aimed to solve an issue that you might have encountered previously when working with text documents, such as essays. So sometimes when you write an essay, you write one version of an essay, and then you make some changes to it, but you don't want to override them, so you make a separate version. And before you know it, you have many versions of the document, and sometimes it's very easy to get lost and know which one is the latest version that you want. So similarly, how Google Docs solved this problem for essays, GitHub does the same thing, but for whole folders of files. So it can keep track of changes to a variety of files at the same time. And it does that and much more. And so when using Git, you can have these different versions of your whole project. You can always go back in time and revert to a previous version. And you can also have multiple parallel versions of the project and effortlessly switch between them. And now we'll see how to use it and how it works. To get started with a project, first I need to create a code repository. A repository will just be a folder that has all of the files required for that project. So all of the code, obviously, any files that you might be using, such as pictures that you might be presenting for an experiment, some CSV files to analyze data, and so on. So to create a repository, the easiest way is just to go on Bitbucket under your account and click on Create Repository. Here you give the repository a name. I will call it test repository. And the rest of the options you can leave as default. Once you click Create, your repository is initialized on Bitbucket, and then you can clone it to your local computer. For that, you click Clone, you copy this command, and then on your local computer in the terminal, you navigate to the folder where you want to put your repository, where you're going to keep all of this code. I want mine on the desktop. And you paste the command. So now I have initialized the repository on my local computer, and I can start adding files and making changes. So now let's make some changes to our repository. Let's say that this repository will be for an experiment in which we will have some code and present some pictures to our participants. So for that, I would add some files, some code files, maybe some text files, and some pictures to be used as stimuli. And once I'm happy with the initial version, I would like to save that version in case I want to go back to it. This is different from something like Google Docs, which keeps different versions of a file automatically. Git doesn't do that. In Git, you have to manually tell it when you want a specific version saved. So if we want to save this current version, we first need to make sure that we are in the repository on our terminal. Let's see, where are we? We're on the desktop. So we simply go into the repository. And we can also see the status of a repository by typing git status. So here we see that Git is detecting some new files in the folder, but it says that these files are untracked. So it's not keeping track of changes to these files. We need to manually tell it to track changes for these files. We can do that by saying git add, and I can either manually type out the names of the different files I wanted to track, or I can simply say git add and dot, and it adds all of the files in the folder to be tracked. Once I've done that, now I tell it to to save the current version by typing git commit, and then I give this version a name. So now the version is saved, and I can make changes, save another version, or I can upload them to Bitbucket by using git push. Once I've done that, if I refresh my repository, we see that all of the changes are synced up with the website. And after I've saved a version, I can continue making changes to my repository. Let's say for this experiment, I decide that I want to change the stimuli. I don't want birds anymore. I want to instead present pictures of bears. I can also change the text file. And I can change code files as well. Once I've made changes, I can use git status again to see all the differences, right? We see that git detected that these files have been modified, some files have been deleted, and some files have been added. So if I want to save this new version, I go through the same process as I did before. I say git add, git commit, and git push. And if I refresh my repository, we see that files have changed. And if I click on this commit link, I can see precise details of what has been changed. So we see the files that we added, we see the files that we removed, and we even see specific lines in our text files that we changed. So this is very useful to keep track as you're making changes to your code base. Now, what if I want to go back in time? What if I want to revert the changes that I made? Let's say in this example, I decided that bears are not the way to go for our experiment, and I want to roll back to the version that had birds as the stimuli. How would I do that? Well, Git keeps a track of all the different changes, and we can see the whole history of those changes by typing git log. Here we see all of the commits that we submitted. So all of the named versions together with the names that we chose. And if we want to roll back one of those commits, all we have to do is note the commit ID. So for example, now I want to revert this commit. So I copy its ID and I type in git revert and I paste the name of the commit. If I click enter, you see that immediately, even though I don't have these files on my computer anymore, Git reverted back to the previous version that had birds as stimuli. So then what I do is I just name this revert as I would any other changes. I just say git add. If I go back to my repository, I see that I've successfully rolled back to the previous version. If you want to see the whole history of the commits, you just type in, you just click on this commits button, and that shows you the whole history of your repository. And by clicking on each of these links, you can see the precise changes that were made in that snapshot. So that is very useful as well. What if I want to experiment with a new feature without overriding the changes that I already made to a repository? What if I want to make some changes in parallel? For that, we can use branches. So this master branch represents the changes that we were making to the repository so far, with each circle being a separate commit. And let's say I want to try out a new type of stimulus, let's say frogs, but I don't want to overwrite the changes that I made so far. For that, we can make a separate branch that is a copy of our current branch and make changes to that without affecting the changes that we made already. Let's see how that would look like. To see the branches that we have already, we type git branch, and we see that we only have one branch so far. To make a new branch, we simply type git branch and give this branch a name. We'll call it frogs. If we type git branch again, we see that we now have two branches. The asterisk indicates the branch that we are currently on. Let's switch to the branch that we just created using git checkout frogs. We see that we switched to a new branch that so far is an identical copy of the master branch. However, the changes that we make to this frogs branch will not affect the master branch. So let's make some changes by adding new stimuli and deleting the old ones. And we can save versions just like we did before using git add, commit, and push. Sometimes if git gives you an error, it also gives you a solution as well. Let's see if that worked. So we see that our master branch is unaffected, And if we click here, we see that we have a new branch with our changes reflected. We can see that here. And so I can independently make changes to both these branches, and changes in one will not affect the other. So branches is a great way to experiment with new features without messing up some sort of a stable master version that you have. If we're happy with the changes we made to the frogs branch and we want that to become the main experiment, we need to merge the branches that we have. Let's see how we would do that. So far, our frogs live on a separate branch, and our master branch still has birds. What if I want frogs to become the main experiment? I want to incorporate them into the master branch. For that, we will use git merge. To merge, we switch to the master branch, using git checkout, and then we use git merge and specify the branch that we want to merge into the master branch. In this case, it's frogs. Once we click enter, we see that our changes are immediately reflected in the code base. And we do the same thing that we always do. If we refresh, we see that we successfully merged our master branch. Another useful command is git pull. So far we've been using git push to take the changes that we made locally and sync them up with the changes in the remote repository. So we're sending the changes to the server. What if there are changes in the server that are not reflected on our local repository? For example, you might be working on the same code base from two different computers, from your work computer and your personal computer. Or what if you're collaborating with someone and they've made some changes to the repository that you want to see? Or, for example, maybe you changed some files on the website and they are not so far reflected in your local repository. As an example, I will use bitbucket website to add a new file to my repository. So now there is a new file on the server that I don't have locally. And if I use git pull, it will look at the server version, and if there are any differences, it will copy them over to my local repository. And we see that that's exactly what happens. So this is very useful if you have changes, if you know that you or someone else made changes to the repository. Before you do anything, use git pull. And if there are no changes in the remote repository, Git will simply tell you that it's already up to date. So it's good to sometimes use it just to check if there are any changes. As a small aside, let's talk about how to tell Git to not keep track of certain kinds of files. Let's say that I have a stimuli folder in my repository that has both pictures and video files. And I just want to keep track of pictures, and I want Git to completely ignore the video files. Now, if I were to use git add, it would automatically keep track of all of the files. However, there is a file called gitignore that I can use to tell it to not track video files. For that, I will open this text file, this gitignore, with my favorite editor. Mine is Nano, yours might be something else. And in this file, I will type in .mp4. Together with this wildcard character, it will tell Git to ignore all the files that end in .mp4. I save my updated gitignore. And now we see that this new folder is synced, but only with the pictures, with the videos ignored. Now let's talk about submodules. As we saw, in your repository, you can have a lot of different types of files. You can have text files, code, pictures, folders. And you can track the history of these files. What if you want to include another repository inside your repository? In this example, we are pretending that we're writing an experiment that has some code to present some pictures. What if someone else wrote some very useful code to present the stimuli better, or to also play a sound? And we want to incorporate their code within our repository. Now, we could simply download their code and include it as a folder, but what if we also want to keep track of all the history of that separate repository? For that, we can use submodules. To include a submodule in your repository, you find the repository that you want to incorporate. So here we have a test module, which is just another bitbucket repository of code. And as we already saw, I can clone it using this command. And this would clone it to my local machine as a separate repository. If I simply copy the address of this new repository and type in git submodule add and then paste the address, this repository will be incorporated as a submodule within my repository. And this is very useful because I can see the history of my repository If I type in git log, we see all the changes that we made. And if I go into the submodule and type in git log, I can see a whole separate history of the changes that were made to this submodule. Those changes might have been made by me or someone else. If I push these changes, we see that a submodule shows up differently from other folders. So you see this icon represents a folder, and this icon represents a module. And if I click on it, it takes me to this independent repository with its own history. To recap, submodules are an easy way to incorporate someone else's code into your repository. So these are the basic Git commands. And let's see what we covered so far. We learned how to make a repository. We learned how to make changes to a repository. We know how to revert to previous commits. We know how to make branches, and we know how to merge them back in. We also learned about git pull if someone else makes a change to our code repository. And we learned about submodules, how to incorporate someone else's code into our code base. There's much more that can be done with Git, but these are the basics, and the text document in the description has more information. So look at that.